Cool. Thank you for coming to this session. We're going to talk about security on SageMaker, right? How to securely deploy the machine learning framework or platform into the production environment, especially in the financial services setup, right? How many of you guys work for financial companies? Cool. That's great. And this whole experience we're sharing today is based on the engagement we had with Vanguard. And today we have our customer joining us to present it together. And in the first half, I'm going to present, my name is Songjie Liu. I'm part of the AWS professional services team, leading the big data and machine learning engagements on the Northeast area. And I'm going to cover the best practices and lessons learned about deploying SageMaker platform into the production environment and all the security considerations we had. And actually, we had a workshop on Monday, which is like a hands-on lab about this topic. And I'm not sure how many of you guys attended that, but this presentation, I'm going to focus more on the best practices and the architecture of the internals of SageMaker. Here's the agenda. I'm going to cover like the major considerations of securing the machine learning platform. And as you guys know, right, SageMaker is not like other AWS services. It has a lot of components in it. It's not a single service. It's like a studio, right, or a suite of services. And the major components include the build part, which is notebook focused, and you can build your algorithm, your code there. And then it's the train, which it spins up the training environment that runs the algorithm against the training data. And then it's the evaluation, right? We have a component called batch transform, and that tool you can use to run against the test data to evaluate the trained model. And the last part is we're trying to make it easier for you guys to host the machine learning model as an API, and you can invoke the endpoint. Right? So these four components are the major focus for this presentation. And here are 6 common security considerations we have, like based on our experience. We're working with different customers. And the first one is, of course, the private network connection, right? And if you come from FinServ, well, no need to say, right? It's always no internet connection by default, right? You don't want your business users or your developers to download or do anything like interactions with the internet without any control, right? The second part is authentication. Basically, when user coming in, you want to know who they are, right? And the next thing related to it is after identify who the user is, you want to know what you want to define what they can do, right? What permissions they have. That's the authorization part. And the next one is data protection, right? Which you need to follow the general best practices on AWS and secure the data at rest as well as in transit, right? We have certain configurations and best practices we recommend. The next one is the artifact management. This is like one aspect a lot of people don't think about at the beginning. And this is really something we've learned by working with Vanguard is as you are moving, like building your models, training, right, you're creating a lot of artifacts. It's not just the model, but also the libraries you're using, right? And SageMaker is Docker-based. You have different type of inference images. You have the training images, right? All of these are artifacts. How do you manage them? Right? So there are certain best practices to follow. And the last one is about auditability. And no need to say, right? In FinServ, you have a lot of compliance, you have regulations, you need to know what user did what, who did what, at what time, right? And auditability gives you the ability to trace back all the activities on the platform. So let's start with the private network activity. And in this part, I'm going to share some of the internal architecture of SageMaker, right? And as you can see, SageMaker components, I mentioned notebook training infrastructure and hosting infrastructure, they follow the same practice, right, when deployed in the SageMaker VPC. This is slightly different from the VPC managed in your account, right? Because SageMaker as a managed service, they have something we call the service account. So after you launch the notebook or the training job, all of these are EC2 instances, but they're running in a service account managed by the SageMaker team, not in your VPC. So how the network flow works will be shown in the next slide. And we encourage the users to configure, if you have the requirement to have everything run in a private subnet, right, configure the following endpoints, right, to make sure it doesn't talk directly through the public internet gateway through the managed account, but redirect the traffic back to your VPC, and everything's under your control. And we also recommend users to further control through the VPC endpoint policy. Let's start talking about like the default setup of the notebook, which is your build environment for the algorithms. So by default, you can see on the right-hand side is the managed VPC, right, by the service account. And that one, you can see it here, but you don't really see it in your accounts, right? And by default, you can see there is an internet gateway that routes all the traffic to the public endpoint, right? If you understand how AWS works, everything is an API call, and we have all the AWS endpoints in public. And that's how, like when you submit a training job, right, that's an API call to AWS endpoint. And even it's in the AWS managed account, it goes through the internet gateway and goes through the internet, right? That's definitely not ideal, right? That's why when we're working with customers with such requirements, we recommend them to disable that, right? On the console or the API calls, it's a parameter you can, like, it's a switch you can do to turn it off. So after doing that, right, the traffic is redirected back to your VPC, sorry. Yeah, back to your VPC. You can see, right, after disable that, there's no traffic going through the internet gateway on the managed account, but everything comes back to your VPC. And you can either have like a controlled like firewall or things, or use VPC endpoint, which is the recommended practice because that will make sure all the traffic goes inside the AWS infrastructure, so nothing goes through the internet. And here is an example of the policy, how you can control the IP, right, to access the notebook, because the end users use their own laptops to access the notebook, right, which is a Jupyter notebook. If they are using their laptop at home without VPN into your corporate network, right, that's definitely a security risk. So you want to make sure they can only access through certain range of IP or through a certain VPC or VPC endpoint. And here is an example of the control, right? Using the IAM condition keys to control what IP range or VPC the traffic comes from. And this is like after configuring that, right, you enforce the user to go through your corporate range, so their traffic initiation will be validated by the IAM, and the login or the authentication process will be approved. Yep. And next part is the training job. Similar to the notebook, the training job also runs in the managed account, right, in the managed VPC. And how it works is similar, right? By default, everything goes through that internet gateway, and you really want to use your VPC to control all the traffic, right? And how this works is the ENI created back in your account. And for this is because the training job is not always one single instance, right? You may have some like large amount of training data to train, and many of these frameworks support a cluster mode, right? Depends on which framework you're using. So you can have a cluster of training instances deployed, and each training instance will create an ENI back in your VPC, and that's how it direct the traffic back to your VPC, and everything goes through the VPC endpoint after that. And this is the recommended practice, right? After turning off the switch to go through the default internet gateway, everything goes back to your VPC through the ENI and through the VPC endpoint. After turning that off, right, you need to add certain parameters when you're using the notebook. This is a screenshot of the SageMaker notebook when you're making a call to create like a TensorFlow training job, right? You can see there's parameters you need to give, like the subnets and security groups. Those are the subnets and security groups in your VPC. You need to make sure you specify them. Otherwise, like it doesn't really know like to use these to set up the infrastructure by configuring the ENIs for you. Yeah, the next thing is the hosting, right? Which is the the biggest benefit we bring to you by enabling this SageMaker as a service is like help you automate all the deployment of the models and create an endpoint through the AWS endpoint. So your algorithms or your applications can make invocation to these endpoints. And again, by default, you can see everything is through the internet, right? And how this works differently is like we have a specific VPC endpoint just for the runtime environment for the running model. Right? This is slightly different from the others, right? There's a set of different SageMaker VPC endpoints you need to enable for the APIs, right? You need to enable the VPC endpoint for the API calls, which like allow all the traffic to the SageMaker to an endpoint to create a job, to create a notebook, right? And for this one, is simply for invoking that model, to invoking the endpoint. So that gives you like better, finer grained access control to it. And here's an example, right? When you're training the job and you will generate a SageMaker model. And in that model, right, you need to specify what security group, what subnets you will have. And after that, when you launch the host service using this model, it will be automatically set up. Here is an example of the VPC endpoint policy, right? If you're familiar with the S3 endpoint, this is similar, right? You can further define like all these, where it comes from, what S3 bucket, what S3 permissions are allowed, things like that, right? Through the endpoint policy. The next topic would be the authentication and authorization. Because SageMaker by design, this notebook is not a shared environment, right? We use Jupyter Notebook and Jupyter Labs. It's not Jupyter Hub, which is defined like as a multi-tenant environment. Instead, we want to have every data scientist to have their own environment to develop the code, right? So if you're enabling these for your data scientist, that should be in the consideration, right? It's not a shared environment. That's why we want to track, okay, make sure data scientists coming in and they create the notebook, and only himself or herself can use this notebook. It's not overlapping with someone else, right? And by doing that, right, we're using IAM and the tag-based access control to make sure after you launch the notebook, your identity is attached to the notebook, and when you're logging in, you're actually authenticated through the corporate federated AD, and make sure only the tags with your name or with your corp ID can access that. And here is a list of IAM roles when you're using SageMaker or when you're deploying the SageMaker environment, which is quite a long list. As SageMaker itself runs on EC2, and all these training jobs host instances are following the EC2 patterns, right? Which to define the permissions in order to, for example, accessing an S3 bucket, right, you need to give the S3 permissions defined in IAM, right, as a role. And the execution policy, or what we call the execution roles, are for that, right? For example, if your training job needs to read the training data from S3 bucket, right, you need to define a job just for that instance and delegate it to the SageMaker service. For the transform job as well, right? For all of these endpoints, it's a running EC2 instance, so you need that as well, right? So the list is like based on our best practices working with different customers. This is the recommended practice. And if you're interested in the details or example policies, we have our workshop on Monday, and all the docs are available online. I can share with you guys the URL if you're interested. And here is the policy, right? How you define the notebook. With that, you can see the AWS user ID, right? That's a specific AWS reserved we call it macro or something like that can pull your federated user logging into the console, right, to show it there. And when the instance is launched, that username will be populated by the login or by the launching user. And after the instance is spun up, you can log in, and that will be validated against your login username. If it doesn't match, it will block the user from accessing the notebook. Here are some additional configurations if you're enabling the VPC, the private VPC, right? Because as I mentioned, it's using the ENI, the Elastic Network Interface. You can see you need some more permissions to create the ENIs back in your VPC or in your account. And these are the recent features SageMaker team added, right, which can help you further control in the API calls, right, this is IAM condition keys, like I mentioned before, similar to the tags we put there, right? You can make sure when the users are making the API call to create training job, they have to specify the security group IDs and subnet IDs and all of these, right? Because you really want to control the client on the client side, right? They're making the APIs in the proper manner. So after the resource launches, it's follow the best practices, right? But we also have like detective controls, which is event-based by Lambda triggers, and they can detect if you're not following the best practices of launching the resources in the subnets, it will be terminated immediately, right? That's the original design when we're working with the Vanguard team, because like back then the security, like these condition keys were not available. Talking about data protection, this part is relatively simple for SageMaker because it's like built into the service, right? And for all the data you stored in S3, of course, follow the best practices of using S3 server-side encryption, or if you have specific need, right, you can use the customer key, right, the key you control. And for the EBS volumes, right, EBS volumes are used on the notebook, the training job, and the host instances, right? So it's the same best practices for EBS to use KMS to enable them, right? To enable the encryption on them. And for some algorithms that can train in the cluster mode, right? You want to make sure all the traffic between the cluster is encrypted if you have that requirement. Like for example, for Vanguard, they require everything in the cloud to be encrypted, right? No matter it's stored at rest or it's in transit. So this one is very important for them. And the SageMaker team like enable this feature based on a lot of requirements from these type of customers. And it's a simple switch you can enable, but you definitely will introduce certain level of downgrade of the performance. So that's some considerations to have. Right? If you don't have that requirements, it's definitely fine. You just use the default mode. It won't encrypt all these in-transit communications between the nodes. And this is like how you enable the EBS volumes, right, and the S3 using KMS. And as you can see, right, in the API call, there is a switch you can do to enable that inter-container traffic, right, encrypt inter-container traffic. That's how you enable the intercommunications between nodes. Okay, artifact management. This is an important topic, as I mentioned, because this is really the lessons learned and the challenges we have during the engagement. And there are a list of different types of artifact you need to manage, right? Here is a better example. Yeah, let's start from this one. And so for SageMaker, right, the major focus of the data scientist is to build the algorithms, right? But also you have the Docker containers you need to manage, which runs on the training job infrastructure, right? And after you deploy to the host endpoint, you need to have an inference Docker image, right? All of these needs to be managed using a centralized artifact management or like a dependency management system, right? And for the Docker, right, we're using ECR, right, the Elastic Container Registry, which comes with the ECS, right, by Amazon. And for some of the like the Python libraries or R libraries, right, we use Artifactory, which is a third-party tool, right, to manage all of these dependencies. And for models, right, there's different concepts of models in SageMaker. The one thing is the SageMaker model, which is actually a wrapper of the machine learning model in the traditional context. Like the traditional context after you train the model is basically a file defining like the formula you trained, right, with all the coefficient field. And in SageMaker, right, the model is on top of that defining, okay, what IAM roles you will be using, right, for the hosting service, because it's basically you use the model to define the environment of the hosting service. And that's why, like, after the model artifact is created, is dumped into the S3, right? And we recommend you guys to enable S3 versioning to make sure you track all the versions of that. And for Vanguard use case, right, they will dump the S3 the train model from S3 to the artifact management system. And this is an example how to use SageMaker lifecycle configurations to further configure your box. Because sometimes you need to install some libraries. For example, you need pandas or some other machine learning libraries or Python libraries not available by default on the SageMaker instance, right? And you can use this script, which is like a bootstrap script for other services like EC2 or EMR, to write a bash script and import or install the libraries before the instance launches. And these, like, you have the create notebook script and the start notebook script. So the create one, it runs only for the first time the notebook is created, and the start script runs every time the instance is started, because you can stop the instance while it's not running. And this is the library and repository management I talked about. For all the code, right, I would suggest you guys to enable the Git-based version control, right, which we support code commit and GitHub, right, through the SageMaker notebook. And for all the others, like the Docker containers or the model artifacts, as well as the libraries or the RPM packages, right, use something like archival or artifactory, right, to manage like in your environment. Okay, the last consideration is the auditability, right? And again, you should follow the AWS best practices of enabling CloudWatch and CloudTrail logs, right? This will give you the features so to track all the activities happening on the training instances, on the hosting instances, right? Your invocation, tracking all the behaviors like that. And we're working with the SageMaker team to enable the end-to-end traceability of the user. So whatever like the user do on the instance or the training job they deployed, right, their username will be captured at the lowest level. So that will give the best auditability, and that's the work in progress. Here is some example of the Jupyter logs, right? The notebook is Jupyter-based, so CloudWatch will capture all of these, and by default, right? This one you don't really need to enable, and this is by default enabled. And this is a training job. You can see, right, in this training job, it tracks like what algorithms you're using. This is XGBoost, right, and when it's got launched, and what are the trees look like, right? All of these will be captured by CloudWatch. And here is a CloudTrail capture, which capture all the API calls to the endpoint, right? And you can see this one is a create training job API call. That will capture like when this call was made, what role is made, right? And that training job name itself, what S3 bucket it's going to access, and all of these will be captured. And further down, if you're familiar with CloudTrail, right? CloudTrail can support S3 object level events, right? Which capture the access behavior of every S3 file or object. And after enabling this, right, you will be able to track the specific activity against the single or every S3 object in your bucket. And this is the example of CloudTrail call API call capture for the create endpoint API. A list of SageMaker compliance programs supported. You can find out more in our documentation, including all these SOC and PCI and HIPAA, right? Okay, now I'm going to hand it over to our honored guest, Ritesh from the Vanguard team, to talk about the Vanguard journey. Thank you.
Hello, Ritesh Shah here. I work for Chief Technology Office as a Senior Program Manager. I have a team of engineers who enable analytics, data lake patterns, and machine learning platforms for reuse at Vanguard by everybody. The theme today is going to be around machine learning and deeper dive on how did Vanguard enable SageMaker over the last 8 to 10 months. Before we go deeper, 2 questions. How many of you know Vanguard overall and what they do? Okay, we have maybe 50%. The second question is, how many of you have started using or embarking on using SageMaker as a machine learning platform? Okay, 10, maybe 20%. So First is the easiest slide, right? What is Vanguard? Vanguard's one of the largest investment management companies, and the core purpose is to stand for all investors, treat them fairly, and give them best chance for investment success. That's the core purpose of Vanguard as a company. Agenda. Let's start with what are we going to talk about today, right? What problems are we trying to solve using machine learning? Example, use cases, etc. Some foundational requirements and capabilities that we have to meet. What is a typical life cycle of machine learning at Vanguard, and what capabilities we look for in that life cycle? How did we enable the platform? And some speed bumps or issues that we ran into, and where are we taking this platform in 2020 and beyond. Let's start with the use cases. We have multiple business lines. One of the business lines that we have is retail, and it also focuses a lot on client experience. Client meaning all of you as investors who have accounts such as a mutual fund account or an IRA account, right? So the first use case is about you're on the web page, but you need to call for some reason. So we build models to predict whether a user going onto a web page is going to call or not. And if we can predict that, we can put call deflection content and route them to a call immediately rather than them having to stumble through the website and then call us a couple days later. So how do we identify callers quickly? Next one is around if you're upgrading your account, how do we make that experience very seamless for you? And we build models to improve that web experience for people. Last one is repeat callers. If you have called Vanguard, we collect data through different channels when you call us or you go on website, and we wrote models to identify, are you going to call us second time or third time? Are you going to be a repeat caller? Repeat caller is a cost which is more expensive to Vanguard than keeping you on the web and solving your problems that way. And identifying those key drivers for repeat call help us improve the website and prevent those calls in the first place. Next set of use cases are around enterprise advice, which is a service that we offer. First one is around you could set multiple goals, and based on your different scenarios, it gives you a what-if analysis of your investment success. Next one is wage growth prediction. So as your wage grows and around inflation and inflation curves, it helps you identify how much you should save for Social Security versus other options that you have. Emergency savings, we have a way to say different tiers of emergency savings, and based on what tiers you are allocating emergency savings, we provide you advice on how to invest that money. Last but not least, right, next dollar accumulator. Based on your demographic investment goals and what you have already invested, models tell you what is the next best place for you to invest to achieve greatest return that you're hoping for. Before we go into how we enabled it, let's talk about some business and technical requirements, right? First one, we all wanted to enable a platform that was at an enterprise scale. We didn't want to enable something that works for pieces of the whole life cycle, rather have a platform that works end to end. And on top of using this platform, we want to use this platform on the data lake that has been built out. We have almost a 2 petabyte size or more data lake already built out, and we want to use all the data for machine learning. Like I said, potential end-to-end data science as a platform. What does end-to-end mean is typically you build a model, train a model, and then run inferences based on batch or APIs. We want a platform that scales across the whole spectrum rather than different segments. And then as you see the use cases, real-time predictions is one of the most important things that we are trying to achieve or we wanted to enable when we started down this journey. From a technical perspective, as a financial services company, security is the most important thing, right? And from a security perspective, we look at it from three perspectives. First is the authentication. We need to identify who the user is, who is training, who is deploying, who is using the APIs, etc. We also layer in authorization. Is this user authorized to the data that they're training their model on, etc. But last but not least, audit every action they perform. If they are building the model, preparing a data set, training a model, we want to audit all their actions so that if a regulator or an audit comes across saying who deployed this model and what training data set was used, we should be able to identify all the pieces required for us to backtrack all that information. While we build a platform for data scientists, we want to make sure there's minimal IT support needed so that data scientists, once they start using the platform, they don't have to worry too much about calling IT for every step of the process. And to help minimize IT support, enable CI/CD as a mechanism for deployments of the whole platform or a component of the platform. And as I alluded, while we achieve all this, we still need the platform to be data scientist friendly. If it's not data scientist friendly, they are not going to use the platform, and then there's no value in putting so much effort into this platform. Lifecycle, I'm going to try to go through a few slides all at the same time. Okay, so from a lifecycle perspective, Vanguard thinks in these different pillars or phases. You first build a model, and you have certain capabilities. For building a model, the platform we chose, SageMaker here, is a notebook-based interface and works as an IDE. You all heard at the keynote yesterday, they launched a full-fledged IDE for machine learning called SageMaker Studio, which is something we provided a lot of requirements around. Model repository and collaboration is very important because anytime a team builds an experiment or is on an experiment, they write multiple models and they want to share it again between the teams. Data exploration to prepare their data sets for all these phases, they need the tools to do that, and which is very important. Last but not least, under the build section, an ability for data scientists to choose pre-trained native algorithms and frameworks that are well-tuned with GPU and other instance types, but also provide them an ability that if native algorithms don't work, they can bring their own algorithms or frameworks into the platform to achieve their work. Next section is train, where the platform should support a single instance training or multi or clustered training. But also while you perform the training, we had goals to start reducing the cost of training because training in a clustered environment can be cost prohibitive at times. And what are the techniques where we can reduce cost? Next life cycle phase is around validate. Once you train the model, you need to validate its accuracy. Does the platform have all the capabilities needed to do hyperparameter tuning, etc., for their model? Deploy phase is once you are ready, saying my model works as I deem it to work, you should be able to deploy it. A data scientist should be able to deploy it themselves using CI/CD pipeline all the way to production. And also, once the model is deployed, does the model automatically scale? Like if we start with 10% of the traffic of the website and grow it to 100%, does it auto scale to infer information quickly? The last two pillars are around governance and monitoring of the model. Governance is from a perspective of auditing. Can we backtrack every model that is published in prod to who created it, how did they create, what data set did they build, etc. This is a capability. The whole pillar as a capability was introduced as part of the SageMaker Studio announcement last evening, or last morning actually. And then monitor. This is a phase that we did not enable much this year, but was part of the requirements, where once you deploy a model, either as an API or as a batch inference, models based on situations and data tend to drift from their original prediction. Can we detect that? And based on that drift and thresholds for the drift, can we either notify the creator of the model or automatically start retraining of the model and redeploy as a full-fledged automation of the lifecycle? We talked about capabilities, so I'm going to dive deeper into how did we enable each one of these capabilities step by step. So as I said, we wanted minimum IT intervention. So if there is a project that starts up saying, I want to build this machine learning model, they would reach out to IT, data scientist or the team would reach out to IT, provide them what data access requirements they have. And once that information is provided, IT team sets up a SageMaker notebook instance as a service catalog product. What it means is, at that point, once IT has deployed that product in production, data scientist goes to the AWS console, goes to service catalog, and they would see a product called Ritesh's experiment. And when they click on it, it will spin up the EC2 instance for Ritesh, and it would lock me into that EC2 instance, and I can start building my model at that point. The reason why we did that is we wanted everybody in the team to have their own development environment, so that when I write my code, it does not negatively impact somebody else's code or compute needed for that code to run. So here you can see the data scientist comes in, launches the product to service catalog. SageMaker spins up a notebook instance for it. That notebook instance is pre-wired to data. And in this diagram, you see a bucket called S3 data, which is the data lake bucket. But we also provision data scientists a S3 bucket into which they can write the outputs. Many a times when you want to build a model, you take data set from the data lake and take a percentage of that data and store it locally somewhere where you can play with that data. So we provide them a read-write S3 bucket. The other important thing is, once the data scientist finishes building the model, they can check it into code commit, and that's already pre-wired for the data scientist. So data scientist doesn't have to wonder or worry about how do I integrate into code commit or a code repository. Also, the notebook is pre-configured to use all the native algorithms and frameworks. And the data scientist can go right into the notebook and use any of the native frameworks or algorithms. If they have a need to bring in a custom algorithm, example TensorFlow, a version that may not be available as a native, they can still bring it as a custom algorithm, as a custom Docker container, and they push it right into the ECR infrastructure that has been enabled for them. Going a little deeper into how the build works, data scientist at Vanguard would try to log on to AWS console. We use custom federation broker to authenticate the user to the AWS console. And once they're authenticated, they get to the management console area. Through the management console, they go to service catalog section where they would see their product that they are authorized to see based on IAM privileges assigned. They click on the product and say, spin me up this EC2 instance, or they can provide what type they want. And then they would spin up the SageMaker notebook in SageMaker VPC. as Sanji mentioned, right, as a best practice, SageMaker VPC, the whole setup is set up to communicate through ENI into Vanguard's VPC, and all communications between the SageMaker notebook and the data happen through S3 endpoints so that it doesn't go over public internet, which was a core requirement for Vanguard to use SageMaker. Next phase, after you build a model or after a data scientist builds a model, data scientist would work in the same notebook environment that he had provisioned for building a model to train the model. Through the notebook interface itself, they can set up any type of training, a single instance or a cluster. And once the training job is complete, it creates the model artifact. Many people call it as a tar.gz file containing all the model and its secret info or secret sauce. And it's put into the sandbox bucket that I described. That was another reason why we enabled an S3 bucket for data scientists to be able to write into. Now, data scientist has trained his model, let's assume on 80% of the data set, and now he's going to use a 10% holdout data set to validate whether the model works as desired or not. What we do is, through the notebook interface, we spin up a batch transform job, and with the 10% of data, it would validate the model and produce the output, which data scientists reviews whether it meets the prediction that they were looking for. If it does, that's when we deem that the development life cycle of a model is complete, and the model is now ready to be pushed to production as an endpoint or as a batch inference. Now the question is, how do they do that? What happens is, once the validation is complete, they get this model tar.gz file, model artifact. They upload that artifact from production right into Artifactory for version management. We as CTO also provided base CloudFormation templates that will allow to deploy it as an endpoint, so that data scientist just has to come in and provide configurations. They don't have to worry about how to use the deploy API or anything. They just go to a code repository. We use Bitbucket. They provide configurations there for their model, meaning what is the variant, what is the model URL, what is the container, TensorFlow, whatever has to be used. They provide that configuration. And the whole build process using Bamboo orchestrates taking the model artifact, the configuration, and deploys the entire payload as a API in an engineering account, which is nothing but a development account. There's some testing done. Then the same data scientist deploys the API into a test account. They test that API. And then when they are ready, they open the process automatically opens a change record for audit control and deploys the API into production for them. This is a whole CI/CD infrastructure that was custom built out so that data scientists can deploy APIs or batch inferences themselves without having to call IT all the time. This slide provides you a deeper dive into how does the whole deployment work. Like I mentioned, there is this box where CTO provides a bunch of reusable artifacts, and the data scientist provides the model and the endpoint configuration parameters. Once they check in, it gets assigned to a reviewer. Reviewer reviews the configuration and then approves it for deployment. At that point, automated deploys take over, merge all this information, and deploy it as an endpoint. And we also provide the data scientist a way to, if they iterate over the model and if they publish a second version, they can assign variants as part of the configuration. Think of variants as a way to deploy the same model, but with two versions. You can say blue-green. This is my blue version, which is production. I introduced a new version. I want to put 10% of the traffic on it, and it will automatically route traffic to it. And then when the data scientist is happy with the outcomes, they change it to full green by pushing another deploy, change to a config. Okay, sorry. Okay, this is a variant, looks exactly same like deploying an API, but think of it as a way to deploy a model for batch inferencing. The only difference is the deploy process deploys the model to production. It never creates an endpoint so that a Lambda or an EC2 instance or a Fargate container or any other workflow could launch this batch inference code. But the whole process was kept exactly the same as API so that the data scientist doesn't have to worry about, oh, for APIs, I deploy the things differently versus for batch. We kept the whole process same for them. As I said, I'll share some speed bumps. I do not know whether you guys can see the differences. There are some things in green and some things in white. The white ones are some things that are still being worked on, and the green ones are some things that we have already resolved, either by custom implementation or by an enhancement by SageMaker team. The first one, which we resolved, was IAM role by default doesn't suffice the authorization needs that Vanguard had and audit tracking needs. So what we leveraged is anytime you spin up the notebook or when the user spins up the notebook, we inject tags onto the infrastructure, and those tags are used to do audit tracking of who used what infrastructure, what model was written on it, etc. Second one was the auditing gap. SageMaker Studio covers many of these gaps. For appropriate reasons, I couldn't mark this as completed because I didn't want to mark it complete before the announcement. But it covers many of the gaps that we had identified from an auditing perspective. Validating model is still being worked on by Vanguard and SageMaker team. What we had to do is to validate a model, we created a batch transfer mechanism. But there are frameworks that provide native model evaluation techniques. Like TensorFlow, you can evaluate it without having to deploy the whole model. But there are frameworks like XGBoost that doesn't provide that capability. So we have requested enhancement to AWS to provide a way to evaluate a model simpler. Sorry, missed few of them. One more area, which was around the lack of KMS key alias support. When we embarked on this journey, data scientists in that notebook would have to give the entire encryption key of the S3 bucket that they are accessing, because all data at Vanguard is encrypted using CMK, customer managed keys. But it didn't have a way to use aliases. So data scientists were running into issues where they would type things wrong or cut paste things wrong, and then their model wouldn't work. So we resolved that by AWS providing an enhancement where we could use aliases rather than just the whole cryptic KMS key. Last one, I think many of you, if you're using SageMaker, would run into this, especially for R. There is no default custom algorithm R container that SageMaker team provides. You have to build one. What it means is you have to install RBase, the OS, everything in your Docker container. We put in a request to AWS to build one for all of us so that we don't have to build a base container, because our job is to add models or frameworks on top of it and not spend time on building these containers. But as a short term, Vanguard built it for our internal use, but we asked AWS to give us a repository that would provide all that. We also asked AWS saying, why does all of us have to have our own private R repository or a Python repository? Can AWS open up a public repository where all the Python and R packages are available, pre-scanned for vulnerabilities, If it doesn't have, it's available for you to use, rather than all of us as enterprise customers building our own repositories for such things. Next slide is, as I said, where are we going with in 2020? The exact life cycle and capability slide is now color-coded with green, which are the things that have been enabled already, and the white ones are the ones that are not enabled. If you look at the theme, when you look at the white ones, things that are not enabled, under the governance and monitoring capabilities, all of those are being enabled through SageMaker Studio. And Vanguard's working on enabling that in next few quarters, and data scientists can take advantage of the SageMaker Studio to enable all these capabilities rather than current way of enabling. The other two main areas we are working on is an ability for data scientists, while they are about to launch a training job, an ability to call Spark or EMR and say, prepare my training data set before I start training. Today, it's a two-step process. They go to EMR separately, prepare their training data set, put it in a location, and then point their training job to that S3 bucket to pick it up. So we want to streamline that experience where through their training job launch itself, they would go and prepare the data. And the last one is around multi-step inference pipelines. We have seen need where data scientists want to chain models, either in sequence or in parallel, where you call one model, which may call 5 other models, and then the output of it is the one that gets sent back as an API. We are about to enable that as inference pipelines capability provided by SageMaker. Currently, it only allows you a sequential call and up to 5 calls, but we are working with AWS to see if we can expand it to be parallel and be more than 5 stages that can be called. Last but not least, right? Kudos to these folks. Sangji, who was one of our best partners helping us enable this from professional services. Ilya, he was the solutions architect from AWS who participated in the journey. Kumar, he's the product manager on the SageMaker side, and Sumit is a product manager on the SageMaker Studio side who partnered with us. And Praveen, a professional services architect, worked with us, and another solutions architect, Raphael. And on the right-hand side, we have a bunch of Vanguard folks without whom we couldn't have achieved this. Hung, a tech lead on my team, one-man army who helped us enable this with all the AWS support. We have a chief AI/ML architect, Robert Zembowitz, who provided a lot of requirements and insights into the whole life cycle, how to approach it. And then we had 3 sponsors or early adopters. Denise Murphy from retail, she funded the whole initiative. And Duffrig from client experience, who utilized these capabilities as use cases. And Amir from enterprise advice, who also leveraged this platform for their use cases. Last but not least, thank you. And hopefully you fill out the survey. And I think we are open for questions on the side, because I don't think there's a mic for all of you to talk through. So we are open for questions as long as you guys have questions.